Here in this video, we want to look at some examples of using the chain rule. And the first example we have here is f of x equals -5 divided by 7x squared minus 9, this whole quantity squared. Now, at a first glance, you may think, well, we could use the quotient rule because we're dividing here. But another option is, instead of looking at the quotient rule, because on top, all we have is a constant multiplier, -5, is the first step here, we could actually just simply rewrite this problem by moving the denominator to the top, and we would have -5 times 7x squared minus 9. But if we move this piece to the top, our exponent now has to change, so instead of a +2, it becomes a -2. And the reasoning behind this is now we have just a constant multiple rule with the -5, and then we have 7x squared minus 9 to the -2, where we could simply apply the chain rule. So here, to start off with the chain rule, if we're going to take the derivative, we need to look at what is the outside function. So when you think of the chain rule again, you're working from the outside to the inside. So it's kind of the opposite if you think of your order of operations, where normally your order of operations, you start on the inside and work your way out. For the chain rule, we're doing the opposite. We want to start from the outside and work your way to the inside. So the outside is the -2. So once again, you would multiply that to the -5. So -2, -5 would be 10 times 7x squared minus 9. And remember, if you decrease the exponent, you're taking one away. So here, the -2 becomes a -3. So there's the derivative of the outside function. So now we need to move to the inside function, and the inside function would be the 7x squared minus 9. So we're going to multiply by the derivative, which would simply be 14x. And at this point, that is your derivative. The only thing we can do from here is to simplify. And if we're going to simplify this, we could take 10 times 14x to get 140x. And if you want to make the exponent positive, we can move this piece to the denominator. So we have 7x squared minus 9 raised to the positive 3 power. And that is our derivative. All right, if we look at another example here, we have the cube root of x to the 5th minus 2x squared. So clearly this is a composite function, and if we really look at this, we actually have three pieces here. We have the inside part is x to the 5th minus 2x, and then we have an outside part squared, and then we have another part where we have the cube root. Well, if you recall, how can we rewrite this cube root? Well, we could write the cube root, remember, if we have the cube root of x, we know that we can write that as x to the 1/3 power. And here, for this example, we actually have the cube root of, let's say, for example, x squared. We could write that as x to the 2/3 power. So if we apply that over here to rewrite this, we could write this as x to the 5th minus 2x raised to the 2/3 power. So once we do this and we want to calculate the derivative now using the chain rule, we have the outside function, which is the exponent 2/3. So again, treat the whole inside like one big variable. So we would take 2/3 out front, keep the inside the same, and subtract 1 from the exponent. So 2/3 minus 1, we would end up with a what? negative 1/3. Okay, now don't stop there. Remember, that was the outside, so now we have to multiply by the inside function, and the inside function is x to the 5th minus 2x, so that would simply be 5x to the 4th minus 2. And once again, there's the derivative. All we have left to do now is to simplify. And here, all I'm going to do is make our exponent positive. So we would have 2 times 5x to the 4th minus 2, all divided by, we have the 3 in the denominator. The negative exponent moves to the bottom, becomes positive. So x to the 5th minus 2x to the 1/3 power. And if you prefer here, you could actually use the cube root again. Instead of x to the 5th minus 2x to the 1/3, you could write that as the cube root of x to the 5th minus 2x. So there's our derivative for this cube root function. Once again, by rewriting, we take the derivative of the outside, then we multiply that by the derivative of the inside function. All right, here we have one more example. And before I say anything, I'm going to see if you can figure out what rule do we need to use here. Well, if you notice, we have f of x equals x squared multiplied by 2x minus 5 cubed. Well, you see the cubed, you got this 2x minus 5, the quantity cubed, so you're thinking, okay, that's going to require the chain rule, and you're correct. But also out front here, we have this x squared. Now, if you notice, that's a little different than what we had up here. When we took this problem up here and we ended up rewriting it as negative 5 times 7x squared minus 9, the negative 5 here out front is a constant multiplier. But in this example, we're not multiplying by a constant multiplier, we're multiplying by an x squared. So this problem is actually going to require us to use the product rule. So now, if we recall, the product rule says that we're going to, in order to take the derivative, we're going to take the first function, which is the x squared, and we're going to multiply that by the derivative of the second function. Now, when we use the derivative of the second function, 2x minus 5 cubed, this is going to require the chain rule. So taking the derivative here is going to require the chain rule. So here we have the main rule is the product rule, but in the process of using the product rule, we're going to have to apply the chain rule for this particular piece here. So that means we would pull the 3 out front, so we'd have 3 times 2x minus 5, subtract 1, so that becomes a square. So there's the derivative of the outside function, but now we need to multiply this by the derivative of the inside function. So 2x minus 5, take the derivative of 2x, and that is simply 2. And of course, the derivative of the constant 5 is going to be 0, so that disappears. Okay, so here we have, again, if you think of the product rule, this is u, and this is our v. But when we go to take the derivative of v prime, I mean, this is then u times v prime, but keep in mind, v prime requires the chain rule. Okay, are we finished? Well, hopefully you said no, because here, this is the product rule. We took the first times the derivative of the second, and then it's going to be what? Plus the second, which is our 2x minus 5 cubed, multiplied by the derivative of our first piece. So the derivative of x squared would simply be 2x. So here is the derivative for this particular function, which required the product rule. And once again, inside of this product rule, we had to end up using the chain rule. And from here, we can do a little bit of simplification. We have x squared. Notice here we have the x squared, the 3, and the 2. So we can make that 6x squared multiplied by the 2x minus 5 squared. And over here, really, there's nothing we can do here because we can't distribute the 2x because the 2x minus 5 is cubed. So I'm just going to write this as 2x times 2x minus 5 cubed. And really, that's okay to stop there. If you want to go a step further, the next step here to continue simplifying this, we could actually factor. And again, as a warning, some of these multiple choice practice and quiz problems tend to have a lot of factoring. So here we can actually factor out, we have a 2 in common. Each factor here has an x in common. And we also have a 2x minus 5 squared in common. So we're going to be able to factor out a 2, an x, and we also can factor out a 2x minus 5 squared. So if we factor all of this out, the factor a 2 out of the 6, you're left with 3. Take an x out, so you're left with 3x. And we took out the whole 2x minus 5 squared, so all we're left with in the first piece is the 3x plus, and on the second piece we take out the entire 2x, and we take out a 2x minus 5 squared, so we're left with simply 1 of the 2x minus 5s. And from here, hopefully you can tell we could simplify a little more. Again, I'm going to leave this. Can we distribute the 2x? Well, the answer is no, because the 2x minus 5 is squared. So please don't try to distribute that. You'd have to square the 2x minus 5 before you could do that. So we're just going to leave this in factored form. Now, inside of the brackets here, we have the 3x plus 2x minus 5. So we could actually add 3x and 2x, because the parentheses here, we don't necessarily need the parentheses around the 2x minus 5. So if we distribute here, we get 3x plus 2x minus 5. So the 3x plus 2x is 5x. So we're left with 5x minus 5. And that is your final answer. Now, of course, there's some other things you could do here if you wanted to. At this point, as an option, just to point this out, we could take the 2x and we could distribute the 2x to the 5x minus 5, and we could get 2x and 5x would be 10x squared minus 10x. And then, of course, all of that would still be multiplied by the 2x minus 5 squared. All right, now really, as far as I'm concerned, you could have actually stopped up here sooner with your derivative, but realize it does look a little bit nicer if you go through the simplification. So again, one warning, if you see this problem and you take the derivative, and let's say you get down to this point here with the 6x squared, 2x minus 5 squared, plus 2x times 2x minus 5 cubed, and this is a quiz question, you look at the multiple choice answers, and you're like, that looks nothing like any of the answers. Well, they probably factored and simplified, Because if you look at our answer down here, if you compare the answer to this piece here, this really looks nothing like our answer because we were able to factor out and then simplify this. So sometimes if you start looking at the multiple choice answers and trying to kind of work backwards, sometimes it's a little bit harder to see this. So just be very careful and realize if your answer at first doesn't seem to match up, see if there's anything that you can factor out. Okay, so keep in mind the three examples we had here. To review the first one, we had a piece on the bottom and we could simply bring it to the top. In this case, just a constant multiple, so we could just simply use the basic chain rule. And here with a cube root or any type of square root or nth root function, we were able to rewrite this and then simply to apply the chain rule. And the last one here in particular, be very careful. A lot of people get confused here because of the x squared out front. That means in this case we had to use the product rule. Again, with the inside of the product rule, or in the process of using the product rule, we have to use the chain rule. So hopefully this will help you with your examples as you go through and give you a better understanding of how to apply the chain rule.